This video takes you through the steps to get a single-sided fast Fourier transform in FFT or Spectrum up and running in Jupyter Notebook. I launched Jupyter from the Anaconda Navigator just because that's an easy way to get in and get going. We're going to open a new Jupyter Notebook. Once it opens, we will give it a file name and add a title to the notebook. Next, we're going to import the libraries needed for this example. The scipy.fft is where we find the commands for the single-sided spectrum. With the libraries imported, we're going to build a time domain signal. This is a simple example consisting of a single sinusoidal component with a sampling frequency of 2048 Hz and a total of 4,096 samples. Two things we care about are the frequency of the sinusoid, 10 Hz in this case, and the amplitude, which is 1 in this case. When we look at the FFT, we would expect to see those same values. With the sine wave built, the next step here is to take a look at the signal in the time domain, and this plot shows what the signal looks like. Make sure that we have the amplitude correct, scaling correct, and that it matches our expectations. That looks good. Next, we're going to build the commands to calculate the FFT itself. The first command here, FFT, is doing a discrete single-sided fast Fourier transform. For a double-sided, you normally scale by the total number of samples. Since this is single-sided, we're scaling by half that. This command here, the FFT freq, is giving us the frequency domain values that we're going to use in this plot that's coming up when we want to look at the frequency domain results. This plot includes a solid dark circle at the amplitude and frequency that we designed above. It also includes annotations so we can see exactly how that spectrum compares to the values we used to construct the time domain signal. All right, that looks good. Well, I'm going to post this to a GitHub repository, a link down below if you want a copy of the worksheet. Now that you got this written, you can go through, change scaling, amplitude, anything you want, get a feel for how the single-sided spectrum works. I appreciate you all viewing this video. Hope it was helpful.